Welcome, everyone. Let's jump right into today's whiteboard explainer. We're going to tackle something absolutely crucial for your cloud architecture, and that is implementing Zero Trust storage security. More specifically, we're going to walk through exactly how to build a secure private tunnel to your Azure storage using Private Link and Azure DNS Private Zones. If you've ever pulled your hair out trying to get on-premises environments to correctly resolve Azure private endpoints, well, you are definitely in the right place. We've got the architectural blueprints ready to go, so let's get building.
Okay, let's dive into this. Picture this. One of your developers spins up a brand new Azure storage account for an urgent project. They get the storage tiers configured, set up the containers, hit deploy, but they completely skip right past that networking tab. So what exactly happens when you forget to configure a private endpoint? Well, by default, Platform as a Service, or PaaS resources in Azure, don't automatically default to your private internal networks.
The result is publicly accessible storage. Literally anyone, anywhere on the public internet can attempt to connect to that endpoint. Now, sure, you probably have identity checks or access keys in place, but your front door, it's just sitting right out there on the public web. In any modern enterprise environment, that is a massive operational and security pitfall. This one simple configuration oversight highlights exactly why we have to apply zero trust principles right at the network layer.
To solve this, we need a really clear blueprint. So today, we're covering 6 key steps. We'll start with the public internet problem, move on to the VIP express lane, tackle the hybrid DNS challenge, build the private resolver, connect the on-premises DNS, and finally, verify that secure tunnel.
First step, Section 1, the public internet problem, and why default routing completely fails a zero trust model. You know, the core of zero trust revolves around a few non-negotiable principles. First, we must assume breach. That means we just operate under the assumption that the network is already compromised. We also have to use least privileged access, giving users and applications only the exact access they absolutely need. We've got to protect data, and not just when it's at rest, but in transit and in use. And finally, network segmentation. Here's the thing. You literally cannot achieve proper network segmentation if your critical data storage is reachable via a public IP address. We have to logically segment this data to actually protect it.
That brings us to our architectural solution. Section 2, the VIP express lane, where we completely bypass that public highway.
Now, what's really interesting about Azure Private Link is that you can think of it as our VIP express lane. A private endpoint is essentially a network interface that pulls a private IP address right from your own virtual network. It basically drops the Azure PaaS service directly into your VNet. Your traffic stays entirely on the Microsoft backbone network, zero exposure to the public internet. Pretty cool, right?
But we do need to make a critical distinction here, because there are kind of 2 ways to lock down network access. Over on the left, we've got service endpoints. Now, these do let you restrict access to your VNet, but they're still using the public IP of the storage account. The perk, they require 0 DNS changes. But on the right, we have private endpoints. These give you that dedicated, secure private IP address. However, the trade-off for this ultimate VIP lane is that you fundamentally have to reconfigure your DNS. That public fully qualified domain name, or FQDN, now has to resolve to a private IP.
Looking at the reference architecture here, you can see our goal. Notice down in the bottom right, our Azure file and blob storage are completely segmented. Users are coming in through a VPN gateway, their traffic routes through an Azure firewall, and then hits a dedicated private endpoint subnet. The storage account has a private IP. That public internet path, completely cut off. But the big question is, how do those users actually find that private IP?
And that takes us to Section 3, the hybrid DNS challenge. This right here is the primary operational roadblock for most enterprise environments.
If you're working entirely inside Azure, it's seamless. The platform automatically handles resolving your storage account's FQDN to the new private IP using an Azure Private DNS zone. But look at this broken chain when we introduce a hybrid setup. Step 1. An on-premises machine asks its local corporate DNS server to find your storage account. Step 2. That on-prem DNS server, it has absolutely no idea what an Azure Private DNS zone is. So it queries the public internet and gets the public IP back. Step 3. Your on-prem machine tries to connect to that public IP, but remember, you disabled public access to enforce zero trust, so the connection drops. The private endpoint fails simply because the routing directions were wrong. As the old IT saying goes, it's always DNS.
So let's fix that routing. We're at Section 4, building the private resolver.
we are going to establish a managed hub inside Azure to answer these queries.
First, here are the architectural ingredients we need. You're going to need your client virtual network in Azure, a network connection back to your on-premises environment, something like a VPN or express route, the specific private endpoint information, a private DNS zone named with the private link subdomain, and of course the star of the show, the Azure DNS Private Resolver.
Now, the Azure DNS Private Resolver is a fully managed service. That means no patching or maintaining custom DNS server VMs. Here's how we set up the Azure side. Step 1. Deploy the private resolver inside a delegated subnet in your VNet. Step 2. Create an inbound endpoint. This part is absolutely crucial. It generates a specific private IP address in Azure that exists for one reason: to listen for DNS queries coming from your on-premises network. Step 3. Create your private DNS zones, like privatelink.blob.core.windows.net, for example, and link them to the VNet where your resolver lives. Now, Azure knows exactly how to map that FQDN to the private IP.
Next, we just have to tell your on-premises environment where to find those answers. Section 5. Connecting on-premises DNS. So, the crucial point here is establishing a conditional forwarder. Think of it like a highly specific detour sign. You go into your on-premises Windows DNS manager or your bind configuration if you're on Linux, and you tell it, hey, anytime someone asks for an address ending in privatelink.blob.core.windows.net, do not look on the public internet. Instead, forward that specific query directly to the IP address of our Azure inbound endpoint. Once you set this up, the hybrid gap is bridged. Your on-prem server hands the question to Azure, Azure reads the private DNS zone, and neatly hands back the exact secure private IP address. Which brings us to our final step, Section 6, verifying your secure tunnel. Because in a zero-trust framework, we always explicitly verify.
You really have to validate that the DNS resolution is actually working before you sign off on the architecture. Just open up a command prompt and use the nslookup command against your storage account's FQDN. Do this from a virtual machine inside Azure, and then go do it again from a machine sitting on your on-premises network. In both of those cases, the results should drop down through the CNAME record into that private link subdomain and ultimately hand you back the private IP address of your private endpoint. If it spits back a public IP, you'll know your conditional forwarder or your VNet links are misconfigured.
Before we wrap up, I want to leave you with a really vital piece of operational wisdom straight from the documentation. Forgetting to configure private DNS zones is the most common reason private endpoints appear to not work. You can build the most secure, perfectly segmented VIP express lane in the entire world, but if you forget to put up the DNS signposts that tell your applications how to actually find that tunnel, your traffic is just going to hit a brick wall. Applying zero trust to storage isn't just about ticking a compliance box. It's about fundamentally rerouting how data is accessed to truly assume breach and protect against exposure. By combining private endpoints with the Azure DNS Private Resolver, you seamlessly integrate hybrid environments right into that secure posture. So I'll leave you with this. Take a look at your own architecture today. Are your mission-critical storage accounts tucked safely behind a private tunnel, or are they still using the public highway? It might just be time to start building that VIP lane. Thanks so much for joining me on this explainer.